Today's topic is a continuation of our couple of lessons that are going to be dealing with volume and volume computations. Yesterday we dealt with the cylinder. Today we're going to deal with cone. Okay. So first thing is, just to reiterate what we've talked about before, the concept of volume is the measure of space occupied by a solid, and it is measured in cubic units. Now, a cone, and very simple, just thinking of an ice cream cone, is a three-dimensional figure with one circular base connected by a curved surface to a single vertex. Okay, so it's very similar to a cylinder, but all things being equal, if my height was the same and my circular base was the same, it would have less volume because it curves up to this single point. Now the formula should look very familiar. V equals pi r squared h, but it's going to be multiplied by 1/3. Now the way I have students deal with this, which is a lot easier, is to just say V is equal to pi r squared h divided by 3, because multiplying by 1/3 is the same as dividing by 3. And then finally, composite solids, which we've dealt with, are objects made up of more than one solid. Okay, so now let's go through some examples. Again, what's very important when you're doing these problems is to underline the key words, because it's going to be very easy to make mistakes, especially when we're dealing with diameter and radius. Cone shaped. Height is 10, diameter is 8. If you know it's a cone, you're going to use V equals pi r squared h divided by 3. Well, the diameter is 8. That means if D is 8, R is 4, H is 10, and divide that by 3. Now, working with the scientific calculator, what I've showed in class today is the way to deal with this, which is very simple. Let me just call up my trusty little scientific calculator. So bear with me for a moment. And there it is. So it was, and what I want to do, I'm just going to write it up here so you can see what I'm dealing with the calculator. Here's the computation we were doing. Pi times 4 squared times 10 divided by 3. What I recommend for students to do is when anything is written with the fraction bar and you have multiple computations, think of this as in parentheses. Now, it'll work without parentheses, but if I had some addition or subtraction going on up there, it wouldn't. So just get in the habit of doing it with the parentheses. So pi times 4 caret squared times 10, close the parentheses and divide that answer by 3. And I get 167.6. So now I go back to my notes, and I got as my answer 167.6 centimeters cubed. Don't forget your labeling. Please remember to round correctly. All right, next example. I give you the figure pi R is 3.6 squared. H is 4.1. Divide that by 3, and you should get 55.6 feet cubed. All right. Now you'll see that we have a composite figure. What is this figure comprised of? Well, it's two parts, and it doesn't matter which one you do first, but I'm going to do the volume of the cylinder first. So remember that formula is pi r squared h, pi r. Now, 8 is this entire line, which is the diameter. That means the radius is 4. H, the height of the cylinder, is 13. So when I do that computation, I get 653.5 inches cubed. Now I do the volume of the cone, pi r. It's the same thing because it's the same circular base, so 4 squared. But the height of my cone is 8, and I have to divide all that by 3. So I get that to be 134 inches cubed. Since this is a composite figure, I'm putting the two of them together. So I take 653.5, add to that 134, and I get 787.5 inches cubed. Okay? Now, last two examples. I give you certain information, and I'm looking to find the height. Write the formula. Fill in volume, radius, divided by 3. Now, since I've got some division going on this side, I want to figure out what pi times 29 squared times 3 is equal to. So I'm going to go back to my calculator. I'm going to compute, and I'm going to clear this, pi times 29 squared, and divide that by 3. And I get as my answer 880.7. Go back to my note sheet. So now I know that whole computation is 880.7. Now I want to know 880.7 times what gives me h. So I divide by 880.7 on each side. And I get h to be 36 millimeters. There's no squaring or cubing because all I'm asking for is the height, which is one-dimensional. All right, excuse me. Last one, I have a cube-shaped figure that has a cone-shaped hole filled out. Maybe this is some sort of piece of tool that you're putting something in to connect parts or whatever it is. So what do I want to do here? I want to figure out the volume of the large figure, which is the cube. Well, a cube is just a three-dimensional square. So that formula is V is S cubed, which is 14 cubed, which is 2744 centimeters cubed. Then I want to go for the cone. There's my formula. I fill in R. Well, it's half of the 7. H is the 14. It's the height of my cone divided by 3. And so the volume of the cone is 179.6. Now, since the cone part is hollowed out, it's going to reduce the overall volume of my figure. So that's why I have to subtract to come up with my final answer. Okay? So to summarize what we did today is we figured out in a more straightforward situation the volume of cones, and then in a couple of other situations, composite figures involving cones and other figures that had hollowed out parts that involved cones.